Today, we're going to do an introduction into fatigue of materials. Now, most testing of materials is under static conditions, where loads are gradually applied until a material fails. Usually, when we look at, say, a ductile material under, say, displacement controlled loading, we'll generate what's called a stress strain curve, where we'll see a characteristic linear portion where the material is elastic and can recover to its original shape. Once we pass the yield strength of the material, it starts to plastically deform, permanently deforming, until we get to our ultimate tensile strength, at which the part starts to neck down, and then ultimately failure occurs, right? Now, all of this behavior is under static loading, very slow loading of displacement or force until failure. Now, on the other hand, conditions frequently arise in real structures where stresses vary with time, where they fluctuate at different levels, and that generally those stresses are well below the yield strength of the material. So these are elastic stresses. They should be recoverable. This type of loading is called variable, repeated, alternating, fluctuating conditions, but it's also generally called fatigue loading. So it's a case where stresses are just fluctuating over time, and they can be below the yield strength and well below the ultimate tensile strength of a material. Now, the challenge with fatigue is that after a certain number of cycles, a crack will start to grow in our structure, propagate, and fracture will occur. So fatigue, in essence, is defined as the microstructural degradation of a material that occurs when subject to repeated applications of stresses or strains, so loads. Now, fatigue is one of the most common sources of failure in machine components, because usually we're designing components to survive. We're not designing components to statically fail. The first time you use them, they fail. No, we're designing them to last, right? And fatigue is also one of the most dangerous types of failures because it can appear similar to brittle fracture in structures. And can occur sometimes with very little propagation of the crack before fracture. Now, fatigue crack growth, the propagation of the crack, can occur slowly, cycle over cycle. So each cycle, our crack can grow a little bit until we get to a critical crack length, at which fracture occurs suddenly and totally, meaning our part separates into one or more components. And the real challenge with fatigue is that this can occur well below the yield strength of a material. Now, fatigue is also complicated by our boundary conditions. And so we have many different names for different types of fatigue. Mechanical fatigue is primarily just the application of stresses or strains, but it can be under biaxial conditions, so loading in two directions, or multi-axial conditions, where we're loading in three different directions, or our crack is growing at an angle through our geometry. Fatigue can also be due to the thermal cycling, where if we have a part that is under temperature changes, the thermal stresses can induce crack growth. And then the combination of both mechanical and temperature, a high temperature in mechanical cycling gives us the kind of high temperature fatigue behavior. If we combine periods of constant load with cyclic load and elevated temperature, that's called creep fatigue. And if everything is changing, both temperature and stress are both just cycling together in series or out of phase, it's called thermomechanical fatigue. Now, beyond all of these crazy conditions, we can also think about just the effect of the environment, such as if we are in a corrosive environment, the corrosion at the crack tip can accelerate the fatigue failure of a structure. or the combination of stress and corrosion can lead to fatigue failure. And then in things like, say, gears or threaded components, where there can be wear and parts can be interacting with many billions of cycles, things like the kinetic friction coefficient can have a big impact on wear fatigue or fretage fatigue. Now, the most challenging thing about fatigue is that in most real structures, combinations of these effects are actually happening in our components. And so in order to design a component to resist its actual environment, we've got to design experiments that match these types of conditions. So with that said, you can learn more about some of these different types of fatigue with a supplemental video in our supplemental playlist. And on to the next video.